Hello friends, so in this video we're going to be studying the parallelogram law of vector addition. Now, the parallelogram law of vector addition states that if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram, the diagonal of the parallelogram drawn from the point of intersection of the two vectors represents the resultant vector in magnitude and direction. I repeat, the parallelogram law of vector addition states that if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram, the diagonal of the parallelogram drawn from the point of intersection of the two vectors represents the resultant vector in magnitude and direction. That is what it's going to represent. It's going to represent the resultant vector in magnitude and direction. What then could this resultant vector be? The resultant vector is a single vector which would have the same effect in magnitude and direction as the original vectors acting together. The resultant vector, I repeat, is the single vector which would have the same effect in magnitude and direction as the original vectors acting together. That is what a resultant vector would be. Here's an example of a question involving the parallelogram law that's been placed before us. Now it says two vectors 4 Newton and 5 Newton are inclined at an angle of 60 degrees to each other. Find the resultant vector. Now, in solving this, let's illustrate our vectors diagrammatically. This would be the 4 Newton vector, and in order for us to solve these questions involving the parallelogram law, it's worthy of note to let you know that it is always important to fix these vectors tail to tail. We must fix these vectors tail to tail. So we fit the tail of the 5 Newton vector to the tail of the 4 Newton vector. Now, the arrowhead represents the head of the vector and the opposite part represents the tail of the vector. Now, the next step we need to take is to complete the parallelogram. So, we draw a parallel line to the 5 Newton vector and a parallel line to the 4 Newton vector. A parallel line right there. This would be the 5 Newton vector. Now, in solving this, we need to draw the diagonal, which according to the law is the line drawn from the point of intersection of the two vectors, and this would be our diagonal, which is representing our resultant vector. Next, we have to impute our angles. Recall that these two vectors are inclined at 60 degrees to one another. So this angle right here would be 60 degrees. Now, if this angle right here is 60 degrees, then the opposite angle would also be 60 degrees because the opposite sides of a parallelogram are equal. So you have 60 degrees right here. Now, we also need to find the angle opposite our resultant vector, this angle right here. We need to find this angle. Now, in doing that, recall that if we have a parallelogram, let's sketch a parallelogram right here, and we have two sides, these two sides to be 60 degrees, the sum of angles in a parallelogram would give you 360, so we can name here x, and we can also name this angle x. What we are going to have now is x plus 60 plus 60, which would give us 360. Now, this gives us 2x plus 120. 2x plus 120 would be equal to 360. Now, we collect like terms now, moving 120 over the equation sign. So we have 2x equal to 360 minus 120. And in the aftermath, we have 2x equal to 240. Now we divide both sides by 2. Let's move it up. 2x equal to 240. Now 240. Dividing both sides by 2, we have that x now would be equal to 120. 120 degrees. We're running out of space there. Now we have 120 at this angle. Let's write the degree properly. And degrees, yes. And we have the opposite angle to be 120 degrees. 120 degrees. Now we can begin to solve for our resultant. Now notice now that this is a parallelogram, right? And our resultant vector divides this parallelogram into two triangles, one at the top there and one at the bottom. Now to solve this problem, we have to use the cosine rule. The cosine rule. How true? Now, what would the cosine rule be? Moving this upward a bit. Now, assuming we have a triangle. Those lines are not very straight, but we'll make do. Assuming we have a triangle. And we have this point, and this point to be the angles on the triangle, or to be the angles of the triangle. Now, this side would be A, and the opposite angle would represent with a small letter A. Here would be B, and the opposite angle would be a small letter B. Right there. Let's correct that. A small letter B. Now, this side right here would be arrow, and the opposite angle represents a small letter arrow. Now, cosine rule states that if we are to find arrow square is going to be a square plus b square minus 2ab times the cosine of the angle opposite arrow which we are looking for. So that will be cos arrow, which is the small letter arrow, which signifies our angle opposite side arrow. Now, comparing that with the lower triangle of our parallelogram, we have arrow square would be equal to a square. Now our A would be 4 Newton and our B would be 5 Newton. So we have 4 Newton as our A, 4 square plus 5 square minus 2 times 4 times 5 times the cosine of the angle opposite our resultant, which is 120 degree. Now our resultant, now in calculating that, we have arrow square, which is equal to, now 4 square gives us 16, now 16 plus 25, which is 5 square. Now minus 2 times 4 times 5 gives us minus 40, so we have minus 40 right there, times the cosine of 120 is negative 0.5. How true. Now our resultant, we have arrow square, in calculating that, gives us 16 plus 25 gives us 41. Now minus 40 times minus 0.5 gives us plus 20, positive 20. This implies that arrow square would give us 61. 41 plus 20 gives us 61. We take square root of both sides, and moving this upward a bit, we are going to have that arrow our arrow now would give us the square root of 61 would be 7.8 Newton. 7.8 Newton. That's what the value of our arrow would be. So our resultant therefore is 7.8 Newton. Now we have calculated our resultant to be 7.8 Newton. We have to also calculate the direction of our resultant, and calculating this direction now, we are going to name this angle right here theta. Going to name this angle right here theta, and in finding that angle there, we are going to find the direction of our theta. Now we're going to draw this shape downward now, and moving that shape downward, we are going to have a parallelogram. We have a parallelogram. Let's move this upward a bit. Now we have a parallelogram now. That was what we had, and this parallelogram now, let's complete the shape. In completing that now, we had this vector going this way and this vector also going this way. Now we also had the parallel sides. We also had our resultant now to be moving in this direction. So we had our angle here, right? And we found our resultant to be 7.8 Newton. 7.8 Newton. Now we chose to call this angle theta. We are to find the angle of inclination of our resultant to the horizontal. Here is 5 Newton and here is 4 Newton. Now, to calculate the angle of inclination of our resultant to the horizontal, we are going to use the sine rule. Recall now that this angle right here is 120 degrees. Yes, we're going to have to use the sine rule. So, according to the sine rule, we have sine theta all over the side opposite theta, which would be 5 right there, all over 5 would be equal to sine 120 divided by the side opposite 120 degrees now, so that would be 7.8. We cross and multiply now. And we have sine theta times 7.8 would be equal to sine 120 times sine 120 now times 5. Both sides now by 7.8, and we are left with sine theta now. Sine theta equal to sine 120 now would give us 0.8660 times 5 divided by 7.8. So let's move this upward a bit. So we have sine theta equal to 0.8660 times 5 gives us 3.464 divided by 7.8 divided by 7.8. How true. Now in dividing that, we have sine theta equal to 0.4441. That's a decimal point right there. So now we have to find our theta, and this would be the sine inverse of 0.4 now. Let's write that properly. 0.441. Now the sine inverse of 0.441 would give us 26.365. That's what our theta will be, which is approximately 26.4 degrees. So the direction of our resultant to the horizontal would be 26.4 degrees. Recall now that our resultant we got to be 7.8 newtons. That's my time, guys. In the next video, we're going to be solving more problems related to vectors. Thank you so much. See you in the next video.